All right. So we're going to start into this new area. This is where we'll be for probably a good little while, because this is the bulk of what pre-algebra is right here, because this is what you will use going forward into your other classes, whether it be algebra, applied math, and geometry, especially algebra and geometry. You'll be using this where you're working with solving for an unknown, solving for a variable. And when we're talking about solving, we're going to be working with what we call equations. Okay? And the reason why we did everything like the expressions and the PEMDAS before this is because now we use those in this. So we used expressions that introduced variables into the mix. Mixes, using letters in our problems. And we learned how to say like a number plus 7. So if we had this right here, that's an expression that we learned in this last unit. A number plus 7 equals this or is this. Now, if I don't have an equal sign, it is not an equation. It's just an expression, meaning I can't solve for that unless something is given to me. If I don't know what x is, I don't know what this can be. X can be anything. Remember, that's why we use the variables. Is it can be anything. It can change. It's variable. So if x is 3, then we learn from substitution. You put that in. My answer is 10. If x is 5, then we put that in as 12. If x is negative 3, we put that in and got 4. We put negative 3 plus 7. So x can change. So because I don't know what x is, I can't solve this. And because this is not equal to anything, I can't solve it. But as soon as I put an equal sign in something over here, now it's what we call an equation. That word equations, if you look, equal is almost in it. Okay, so as soon as you got an equal sign, now you have what we call an equation. And you can actually solve for this. Now where PEMDAS comes in is as we get bigger, as these get bigger, and even if any kind of math as you go on, you have to follow the order of operations. So, we're going to be using this prior stuff, whether it be how to know what an expression is, how to use a variable, substituting something in, doing PEMDAS. Now we've built to where we're actually solving for variables. Okay, we're going to be solving for them. And now, because I added this equal sign, I can now solve for that x. That x is one specific thing. I just need to find what it is. Okay, now before I put the equal 12, x could have been anything. Okay, it could have been a 3, it could have been a 10. And you have to know what it is to know what this is. They have to tell you x is 10, x is 3. But as soon as you put an equal sign, no longer do you need anything else given to you. You have everything you need to solve for what x is. Now this one we could probably do in our head. What plus 7 gives me 12? Well, we probably know it's 5, But the reason why I want to highlight this for a second is and I think I covered this a little bit before in one of the prior videos, from early math, from elementary, middle school, our unknown was always at the end. Like it was like 8 plus 9 equals, and they put the unknown over here. And you had to just do the math. Well, that changes now. Now we know what the answer is. We just don't know what one of these add-ins are. So our brain has to start working in different ways, has to start working in algebraic ways to solve for what this letter is. Now, like I said, everybody always says, I hate it. I love math until they put letters in it. Just know this is like a blank. It can be anything. It's not necessarily an X. Our rules do come in of what you can combine. But as far as knowing what that is, all you need to know is, okay, what is that going to be? What's that answer going to be? Now, how we go about solving it, now it'd be nice if we could just look at them and know what all of them are. Like, oh, well, that's 5. No, the next one's 10. But they get harder. And so we have to have a process to be able to solve for these, okay? So this process that we are going to use to solve equations is called isolate the variable. And that word isolate takes on a whole new meaning here the last month or so. We know isolate means to get alone. We've had to isolate ourselves. And so you're probably very tired of hearing that word. But we'll take it into the math realm and just say, hey, we're going to just use it for math. But isolate the variable means that we are making that variable be completely alone on, where it's at. Now, one thing we have to do that, so that's what we're doing, is we're isolating the variable. We want to get that variable alone. Right now, it's got something with it. And here's how now I'm not going to do this every time, but it may help you to do it for a little while. That equal sign we're going to treat like a fence, okay? It's this fence. You got this side of the fence and this side of the fence, okay? And the reason why that's important to realize is right now, on this side of the fence, we've got something with the variable. And we want to get it to the other side of the fence, whatever's with it, so that we can isolate and just have the variable. That way, when you're done, you have your answer be x equals this. X equals 2, or x equals 10, or x equals -5 or something. So when we're trying to isolate, we're trying to isolate it on this side of the fence, okay? Now, I have started teaching here within the last few terms, or even, better part of the year, that we're going to leave the variable. We're always going to try to get the variable on the left side. It doesn't matter, okay? It really doesn't matter if the variable's on the right or left side. The equal sign, like if I write 8 equals 8, okay, and we're working with just numbers, it doesn't matter which side, which 8 is on. You don't even know 8 equals 8. It could be either side. So like if I put x equals 8, okay, it doesn't matter if I switch sides, okay? 8 is still going to be what x is, okay? So, in real math, as you go on and you get further and you get a little more practice with this, it doesn't matter which side the variable's on. But for learning it, I've learned it's just best, especially when you get into variables on both sides, to just have the variable on the left side. It's cleaner, it makes more sense, so that when you're done, you can make the statement x equals 8, or x equals 10, or x equals -3 or something. We're going to do it that way so that it's uniform and it's kind of easier to learn the process. Okay, so we're going to keep the variable on the left side. Now these problems we're going to start with, the variable's already on the left side. So that's already been done for us, and we just need to isolate it. Okay, now, to isolate it means we want to get it by itself, and so we want just this left at the end. Okay, so that's our goal, is to have just this on the left side at the end. So that means in this case, we need to move this 7. We need to get this 7 gone. Well, when you're adding in something, in order for it to not to be there, think to yourself, what's the only thing you can add to something and it not change it whatsoever? Well, that's 0. And so we want to make this to where instead of x plus 7, we want to make it to where it's gone. It's a 0. And so the only way you're going to make a 7 a 0 is to subtract 7. Okay? If we subtract 7 from 7, then we're going to get 0. And we're going to be left with x plus 0, which we don't even need that plus 0. It's gone. It's a nothing. So that's the way we're going to get this gone, is to subtract 7. Okay? If it had been a 10, we would subtract 10. Okay, so if it had been a 50, we would have subtracted 50. So it's not that it has to be 7, it's just we're making that a 0. Okay, now, we did that on the left side of the fence. Okay, now I'm going to put up something. I'm going to put that 8 equals 8 with numbers again. And let's say I subtracted 3 from that 8. Just picked a random number, and I get 5. Now, what is the only way that this statement is still going to be true, where the left side still equals the right side? Well, if I subtracted 3 over here, then the only way this is still going to be a true statement is to subtract the same thing over here. Okay? That's it. If I do something on the left side of the fence, I have to do the exact same thing on the right side of the fence so that it's still a true statement. Well, and that makes sense. If you have 8 equals 8 and you subtract 3, then you got to subtract 3 from the other side for it to be true. Well, that premise follows over here. If I subtracted 7 to get this gone, I have to subtract 7 over here as well. Okay? And my equal sign's still here. The fence is still here. But now what's happened is this has disappeared. It's became 0. But over here, this changes to a 5. And remember we said at the beginning, we figured out that 5 is the only thing that x can be to make this a true statement. And so that's how you do this problem to solve for x. Let's do another one of those. Let's say I had, and let's make it harder. where, you know, it may not be as easy to solve, you know, in our head, okay? X plus 23 equals -5. I threw in a negative there, I threw in a bigger number, but I want to show you that as long as you follow this process, you can solve for one like this, okay? So let's make our fence. If you want to do that for a little while, you can. I'm not going to mark you off or anything. Now, eventually, I'm not going to be doing that. I'm just going to have the equal sign going down throughout the problem. But I want to get rid of this 23. It's positive. So I'm going to subtract to make it 0. And if I do that to this side, I have to do that to this side. Now what happens is this disappears. Okay, it became 0. I still have my fence. And now I have -5. If you need to see it side by side, it's -5 minus 23. And our negative rules teach us that if it's -5 minus 23, it becomes -28. Okay, you're going further down the negative side. Okay, so in that case, -28 plus 23 equals -5. I can plug that back in and it's a true statement. Okay, so that's a harder one that shows you that you have to get used to this process to be able to solve for that. Okay, now let's look at just a little wrinkle in this and switch places here with the numbers over here and show you that it's still the same thing though. I have a plus sign, I have this here, and in our head we probably could do this already. No, it's 5 again, you know, but you know what happens when we're doing our process and we've got one that looks like this where this has been switched. Well, we still want to isolate the variable. We still have this side of the fence, okay? We just want to get rid of that 8, and it's a positive 8. So the only way we're going to get rid of it is to subtract 8, okay? That leaves us with plus x, but we know plus x is just a positive x. Okay, when it's all alone, now we don't even need that plus sign. We got rid of this, okay? But if we subtract 8, we got to subtract 8. And so we're going to get x is 5 that way. So no matter which side it's on over here, and it's a positive, you're going to subtract it to get it to be 0. Okay? All right, now let's look at what happens when we have a subtraction problem. Okay? So here's x minus 3. And just know these letters can be anything. They can be x, y, g. You know, it doesn't have to always be x. It's just the normal one that's used the most. Okay? So here's an equation that instead of plus something, we have minus something. We're still going to isolate the variable, and in your head you could probably already figure out that this is 18. 18 minus 3 gives me 15. But we need to know how to do it when the problems get harder. And so just like we needed on the plus signs to subtract something, we need this to be 0. And so instead, if I subtract 3 here, -3 minus another 3 is -6. And so that didn't become 0. That didn't get rid of it. The only way you're going to get rid of this 3 is to add 3. Okay? And that's going to make that 0. -3 plus 3 is 0. And once again, on this side of the fence, you're going to add 3. Okay? And now you're left with 18. Okay, so that's what happens when you have a subtraction one that you're having to move and solve that way. Let's do a little bit harder version of that. And I'll use a different letter. Y minus, let's do 46 equals -27 or something. Okay? So harder because that's bigger and you got some negative numbers in there and you're like, oh, you know, now I can't do it in my head necessarily. Well, in that case, same process though. You want this to be a 0. So you're going to add 46. So you don't have to make that harder than it is. Just add the opposite here. And then over here, you're going to add 46. And so now that one you may have to relook at maybe and like put it here side by side if you're still working with your negative positive. And you know, one of them's negative, one of them's positive. So you're actually going to subtract the numbers. Okay. And get 19. The bigger one's positive. So this is a positive 19. And remember, you cross these out, so all you're left with over here is y, and y equals 19. So in that case, what that means is 19 minus 46 equals -27. If you had $19 in the bank and you wrote a $46 check, you'd be 27 in the hole. Okay, so But that's where the product, you just add 46, you add 46, and that's going to give you your answer over there. Okay, one last wrinkle with this. You know, I flipped places when I did the addition ones. Well, let's flip places with the subtraction one and see what happens, okay? And so, you know, this is a subtraction problem, but really, this is going to start out like an addition problem. Because in this case, you're not going to add 7 like you did on the subtraction one. You know, and just to show you the difference, you know, if it looked like this, you would add 7 to get rid of that 7 to get a 0. But if you, because I switched places, if you add 7 here, you're going to get 14. You're not going to get 0. You need 0 here. So you're going to subtract 7, and it means you're going to subtract 7 over here. The difference is we can't just drop this negative like we did, you know, when it was positive. You know, we didn't need to write a positive y. It's already positive. In this case, we can't just drop the negative. It's a negative y, okay, and we subtracted 7 is 3. And the difference is we can't just stop there. We're not solving for negative y. We're solving for y. Now, I'll go through a little bit more the technical way of what we're doing here, but for now, just to do these real quick and get in the process, instead of having the negative here, we're going to take it off and put it over here. Now, there's a whole reason why, and we're going to go into that tomorrow, but just know if you get down to this, take the negative off and put it over here. And so that instead of negative y equals 3, you have y equals negative 3. Okay? Now, just to show you that this is right, let's put it back into our original problem as a substitution. 7 minus negative 3, that's what my y is 10. And this is our substitution. So 7, this is a double sign, so it becomes 7 plus 3 equals 10, which is a true statement. Okay, 10 equals 10. Okay, a lot of things there. They're almost so small. These can sometimes be even trickier than the bigger ones because you've just got little things about them. But go back through, watch each one, and then you'll be able to do this assignment. Okay, so I'm going to put the, I've got, I think 9 problems here, variations of those. Okay, so you're going to do these and take a photo and upload them. So number 1 is x plus 12. And go through the process. Don't just, you know, okay, that's 3. Go through the process and actually solve that for 3. So I gave you the first answer, but I think that one, you know, you can do in your head. Okay, and so you're solving for the letter. Okay, so 9 plus y equals negative 13. And we got some subtraction ones here. X minus 3 is 10. X minus 7 is negative 3. Y minus 52 is 13. That's an equal sign. 10 minus x. So here's a few that's going to end up with that negative variable. So I put a few of those on here at the end. 12 minus y is negative 3. Okay. All right. Go through those, and then we'll keep building tomorrow, okay?